All right, fourth day of moving plates. This is now phase 2, the processing. That means we're going to be highlighting and annotating. We're looking for the key details in our notes that support the main idea. Okay, so let's go ahead and start with their visual summary. Continental crust is made of different kinds of rock than oceanic crust. Continental crust, different kinds. Okay, so continental crust is granitic, less dense and thicker. Oceanic is basaltic, more dense and thinner. Okay. As a result, continental crust is less dense and thicker than oceanic crust. Okay, we just did that. That kind of makes it float on top, and this would kind of sink or stay towards the bottom of the crust. There's a drawing of the example. Right, there's the continental crust. Here is the oceanic crust, that dark line. We drew the little waves above it. Okay. Convection currents in Earth's mantle drive tectonic plate motion. Okay, so convection currents, that is the circular path in the mantle. Okay, it's in the mantle, and it drives tectonic plate motion. It drives that circular path. The heat pushes up. Some of it can split open through a mid-ocean ridge where the crust is splitting apart. Others of it will cool and sink back towards the mantle. Okay. According to one model, plates are dragged along like groceries on a conveyor belt. So these currents sort of drag the crust or the plates along. And we sort of drew that here with these little arrows pointing away, showing that they're splitting open. Tectonic plates move at an average rate of 10 centimeters per year. Okay, they're very slow, right around 10 centimeters or 4 inches every year. Some a little faster, some a little bit slower. That's about the same rate our fingernails grow at. We use satellites, radar, and lasers to measure movement. So we use satellites, radar, and lasers in order to measuring the plates moving. And that's called GPS. Okay, so that's everything in the visual summary. Let's see which of our key details supports the main idea. Heat from the Earth's interior drives convection currents in the mantle. Okay, is that how they said it? Heat from Earth's interior drives convection currents in the mantle. Okay, so the heat. We need to talk about the heat, so I'm going to highlight it. Now I'm going to use my little red pen to put stars next to the things, right? So we're looking for highlighted stuff that came from this that matches our main idea. So heat, Earth's interior, the interior is the mantle, drives convection currents. It drives this circular path, which is called convection currents. That's all in the mantle. Okay. Move plates centimeters per year. So the plates move very slowly. Only about 4 inches per year. How did they say it? These currents move tectonic plates at rates of centimeters per year. All right, so when we write our paragraph, it's going to be something like, heat from the Earth's interior drives convection currents in the mantle. This moves the tectonic plates at centimeters per year, very slowly. Convection currents, actually let's back that up. Heat in the mantle pushes up at mid-ocean ridges. Well, yeah, okay, let's not say it that way. Heat in the mantle pushes up against the crust. There we go. As it pushes up, it drags the crust and splits at a mid-ocean ridge. Then when it cools, it goes back down towards the mantle, driving a circular path. There we go. Now we've got all that stuff in there. Okay. This happens at a very slow rate, at just about 4 inches per year on average. That's as slow as our fingernails grow. Okay, so we got all that stuff. Notice we didn't put any stars about the measuring and the satellites and the GPS. So that basically means that's optional. We don't really have to put that in our paragraph. Yes, that's important information, but it did not directly support the main idea. You could say the way we know that it moves so slowly is by measuring plate movement with GPS. So let's put a star next to GPS. We'll mention GPS in our paragraph. Okay, that's it for phase 2 processing. We highlighted stuff based on what they gave us in the visual summary. We annotated using stars to match that up with the main idea. And then we just thought about it. How would we write our paragraph? Start with the main idea, add some details supporting it, and that gets us thinking about it. Then when we sit down to actually type it out or write it out in our e-binder, we'll be more prepared. Okay, good job persevering. With growth mindset, roar Wildcats.